Hello everyone, welcome to MBA Karo. Probability is one of the topics which is asked in NMAT. Many a times students do not prepare this topic, especially if you're targeting CAT and other exams. You think that modern math is not asked much in those exams, so people do not prepare it, and there are not many good resources to prepare for it. NMAT has some specific kind of probability questions, and in this video, I'm going to cover all those types, including the ones like infinite GP, Bayes theorem, etc. So please watch this video till end, and don't forget to like and share this video to understand the kind of questions that you get in NMAT. So there are few basic things that you must know that in coin you have two outcomes, head and tail. Okay. In a dice, you have six outcomes: one, two, three, four, five, six, and then you have cards. Cards there are 52, 13 of each suit, and these 13 include ace, king, queen, jack, and numbers 2 to 10. Okay, and these are called face cards. So these are some basics of probability. Like you might be asked coin based questions, dice based questions, card based questions. Okay, in coin they might ask you how many heads can you get. Okay, what is the probability of getting so many heads in so many tosses of a dice coin? Dice you might be asked sum of numbers. Okay, cards like what is the probability to get face card or this card or that card. Whatever basic concepts are same, but you must know the numbers. And then apart from that, you have questions like there are different kind of balls, like there might be some red balls, some green balls, some group blue balls, etc. And you pick certain balls. What is the probability that you get one red ball, one green ball, both blue balls, etc. Those kind of questions. Then you might have a question based on repetition. Okay, I will take example of all these in this video. Repetition basically wherein you have to apply infinite GP, and then you might also get question on Bayes theorem. So in this video, I have covered all these types. I have encountered these kind of questions, people posting in my Telegram groups from their official mock as well. And some of you must have seen those questions also. So you will understand how to solve these questions. All right. So if you are new to the channel, please don't forget to subscribe to the channel. Here you get the best quality content, no nonsense stuff, pure academic content that will help you ace all MBA entrance examinations. So let's begin with a very simple type wherein you have coins being tossed and you need to find out that how many outcomes you can get, like 8 coins, and you have to find the probability of getting exactly 3 heads. Now when 8 coins are tossed, you cannot find like you cannot count all the outcomes. I mean, you know that the number of outcomes is 2 raised to the power 8. Okay, so that is 256 outcomes. Now you cannot write all 256 outcomes. Suppose it was 2 coins, so you can say you can get head head, head tail, tail head, or tail tail. 2 coins you can write. 3 coins if there were, you would write head head head. So in this, still you can write the outcomes. Okay, but if the number of coins increases, then you have to apply the formula. So here there were 8 outcomes. You could still write, but 256 difficult to write. Okay, so and that is a foolish thing to do. Now we are tossing 8 coins. So total 256 outcomes. What is probability? Probability is favorable outcomes upon total outcomes. Total we know 256. Now favorable is we have to get 3 heads. How to get 3 heads? So you should know combination for probability. Okay. So if you have to get 3 heads, we are throwing 8 coins. So if any of three of them, if we pick three of them and they turn out to be head, so we will select, yes, throwing 8 coins, and we have to select 3 coins out of them. Suppose there are 8 coins on a table, you pick any of them 3 and all 3 are heads. So we are picking 3 out of 8. So 8C3. Now 8C3 is 876 by 6, which is 56. So 56 by 256, and you will cancel by 8. So 7 by 32 is the answer. So easiest form of question, you should know the basic of combinatorics. When two dice are thrown simultaneously, find the probability that the sum of the numbers is a multiple of 4. So let me tell you, when we throw two dices, we get outcomes from 2 to 12. Okay. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are the outcomes. And in how many ways can you get the outcomes? So just remember this thing, when you throw two dices, you get these outcomes. The way to remember is till 7, it is n minus 1 ways. So 4, 3 ways, 5, 4 ways. And from 7 and beyond, okay, it is 13 minus n ways. Okay, so let us say we have to get 10. So we can get 10 in 3 ways. In what ways? See, I can tell you that the explanation also, but not needed. You just need to remember this fact. Okay, so you can get 10 like 4, 6, 5, 5, and 6, 4, 3 ways. Okay, so you do not have to expand everything, just remember this rule. Now we have to find the probability that the sum of the numbers is a multiple of 4. What are the multiples of 4? 4, 8, and 12. 4 we can obtain in 3 ways, 8 we can obtain in 5 ways, and 12 we can obtain in 1 way. So this is favorable, and total outcomes are, there are two dice thrown. So first dice can give you 6 outcomes, second dice can also give you 6 outcomes. So this is 36 outcomes. So 9 by 36, which is 1 by 4. That is the probability. We have a four-sided pyramid dice. Its sides are numbered 1 to 4. It is rolled 3 times. What is the probability that sum of the 3 rolls is a prime number? Okay, now this is something which is a different kind of question, not the typical dice. So we have a pyramid dice. There are sides 1 to 4, and it is rolled 3 times. We have to find probability sum of rolls is a prime number. Okay, so total outcomes we know. So there are 3 times 4 into 4 into 4. This is 64 outcomes. Now favorable outcomes. Favorable, what does it say? The sum is a prime number. What are the prime numbers? See, you can have from total from, see, minimum total is 3. Minimum total you will get 3, because even if you get 1, 1, 1 on each dice, all the 2 is a prime number, but we cannot get a sum of 2. So we can get 3, we can get 5, we can get 7, we can get 11. Maximum is 3, minimum is 3, maximum is 12. We cannot get total beyond this. So favorable outcome 3 can be obtained like 1, 1, 1. Okay, so there is one way. Now 5, let us start with 1, take another 1, then we can get 3. Let's start with 1, let us take 2, and then we can have another 2. Okay, now if we take 1, 3, it will again become 1. So same result. 1, 4, 0, not possible. So there are two ways. But within these three dice, see this 3 can be the last number, this 3 can be the second number, this 3 can be here also. So there are technically 3 ways of getting this number. Okay, 1, 1, 3. Like, see, it is basically 1, 1, 1, 3. 131, 311. In all cases, we are getting the total 5 only. So we just write the total, how to form, and write the number of ways. So 3 ways. Similarly, 1 to 2, 1 can come here, 1 can come here, or 1 can come here also. So we have again 3 ways. So we have total of 6 ways to get a sum of 5. Now we will do for 7. So we start with 1. 1, if we take 1, then we can have 5. Okay, which is possible? Not possible, because maximum is 4 only. So we cannot take 115. If we take 1 2, then the third number has to be 4. Okay, 1 2 4. Now if we take 1, if we take 3, then the third number has to be 3 7. Okay, now 1 4 2, again that's done, right? Now if we take off 2, if you start with 2 and you take 1, that is 4, same thing. 2 to 4 is same. 2 1 4 is same thing. So we will take 2. If we take 2 and 2 4, then it is 3. And beyond that we cannot take, because 2 3, if you take 2 3 2, same result, and 2 4 1, same result. Now 1 to 4, we have 3 numbers, and they can be arranged in 3 numbers can be arranged in 3 factorial ways, right? If there are 3 items, they can be arranged in 3 factorial ways, 6 ways. They can be arranged in 3 ways. Again, 1 can come this position, this position, this position. 2 to 3 can arrange in 3 ways. Like 3 can come here, 3 can come here, or 3 can come here. So total of 12 ways. Now 11, we will have to think of large numbers like 4, 4 and 3. That is the only way. And 4 4 3 can come in 3 ways, like 3 4 4, 4 3 4. So total 3 ways. Now adding this, we get 18 plus 4, 22 ways. So total favorable outcomes are 22 and total outcomes are 64. So this becomes 11 by 30. So this is how you count when the outcomes have are arranged also in order. Okay, in this case we have to arrange also. Like 113. Okay, it can be in 3 ways. 1 to 2 can be in 3 ways, because 1 can occupy this position, this position, this position. 1 to 4, 3 different items. So 3 items can be arranged in 3 factorial ways. So this is how you solve this one. Tickets numbered 1 to 250 are in a bag. What is the probability that a ticket drawn has a number which has a multiple of 4 or 7? Okay, now this is also a kind of question which is asked. Now we will find first multiples of 4, then second multiples of 7, and then subtract common multiples. Okay, how many multiples of 4 are there? Like if you count 4 8 12, so what we will do, we will divide 250 by 4 and just take the quotient part. Remainder we will ignore, so that will be 62. If we take 7, 7 divide by 7, so 7 3 21, 4 40, 7 5 35. So we will ignore the remainder, just take the quotient part. Okay, so from 4 we have 62, 7 we have 35. Now think like this, there will be number 28 also, 56 also, 84 also, which will appear in this range also. In this you will get 28 also, 58 also, 56 also. In this also you will get the next number 28, then you will get 56, and so on. Okay, so these are common ones, and we will remove them. Why will we remove them? Because we have already counted it both, like we have counted it 2 times, in 4 also and 7 also. So what we do is we subtract the common कैसे subtract करते हैं? Divide by the LCM of the numbers. 28 into, you will get 8. 28 into 9 is 252. So this plus this minus this. So 62 plus 35, 97, minus 8, 89 are the favorable outcomes. So 89 by 250 is our answer. Okay, so you might be asked question like this: if there are some tickets, they are numbered so and so, or there are some students, they have this roll number. Like how many students? They might ask you the number also. They might, it can be a question number system also. They might ask that there are so and so students. The students whose roll numbers are multiple of 5, they like chocolate. The students whose roll numbers are multiples of 8, like ice cream. Okay, how many people do not like any of the items? So same kind question. First of all, we count the multiples of one number. Second number, subtract common multiples. So that's how we get it. I hope you are enjoying this session. So please don't forget to like this video and subscribe to the channel for great content on MBA preparation. Now let us come to these combination based questions. From a deck of 52 cards, 3 cards are chosen at random. What is the probability that all are face cards? Okay, so there are some cards, there are 52 cards, and we have to find the probability that all 3 cards that we pick are face cards. Okay, now in this case, what is our favorable outcome? Favorable outcome is 3 cards face, and total outcomes is 3 cards picked. Now, from how many cards are we picking these cards? 3 cards are picked out of 52 cards. And favorable, what we need to get? We need to get face cards. Now, how many face cards are there? I told you king, queen, and jack are the face cards of each suit into 4. So we will have 12 face cards. So what is the favorable outcome in this? 3 cards, 3 face cards out of 12 face cards. So 12C3 upon 52C3 combination. 12C3 is 12 into 11 into 10 upon 6, and this also 52, 51, 50 upon 6. Since 6 is in the denominator, we can cut it. Now we have 10 by 50, so this becomes 1 by 5, and 12 we can reduce by 4, 8 becomes 3, and 13 here, and 3 becomes 17. So this is 11. Now you do not need to multiply the denominator. If you see, right, all the options have same denominator. So it must be 1105. Okay, and only 11 is the numerator that you can fit here. So this thing also one must know ki have vigilance. See the options. If the options are such that do not require you to do the calculations, so avoid those unnecessary calculations. Okay, so it becomes 11 by 1105. Now these are the common kind of questions that you get. There are some balls of X color, Y color, Z color, different combinations. Now these are the questions that require combination approach, and I will explain all the kinds so that you will be able to attempt any of these questions if you face in any of the examinations. Okay, so I have taken 5 different varieties. So there are 6 red balls, 4 green balls, 8 yellow balls. 3 balls are drawn at random from the box. What is the probability that all are red, 2 balls are red, and 1 ball is green? One no ball is green. So these are 5 different questions that are being asked. In all these questions, one thing which is common is the denominator will be same. The denominator will be total outcomes will be same in each case. So total outcome is pick 3 balls out of how many balls we have? We have 6 plus 4, 10 plus 8, 18. So that is 18C3. That will be the common denominator in all these questions. Okay. Now talking about the first question, it says all balls are red. Okay. All balls are red means we have to pick 3 red balls only out of the given red balls. How many red balls do we have? 6 red balls. So first will become 6C3 upon 18C3. So we'll pick all 6 out of all three red balls out of these six red balls. So 6c3 by 18c3 will be 654 upon C. It is C3, so upon 6 over in all cases. So we can just avoid writing upon 6 and both. So 18, 17, 16. So this is 3 times, 4 times. So this becomes 5 upon 6 is 3 times, 4 is 4 times. So 5 upon 68 into 3, 204. Okay, so this is done. Second is two balls are red and one ball is green. So two are red means we are picking two red balls from 6 and one green from 4 upon the denominator remains same only. Okay, so this will be 6c2 into 4c1 green balls. We are picking one green, 18c, 6 into 5 by 2 into 4. Okay, so this is 3 into 6 is 18 and this is 4. So 5 upon 17 into 4, 68. So this was 5 upon 204, 5 upon 68. The third one is no ball is green. No ball is green means that we will pick apart from green balls. We will remove these green balls. Apart from 12 balls, we will pick 3 balls. Okay, so you just have to remember whatever is asked, that is basically out of the given. Like here we said that 4 green balls. So all balls are red, so we will pick only from this. Okay, now we do not have to pick green balls, so we will remove green balls. So we will pick 12c3 upon 18c3. So you just have to keep in mind from where are you picking the balls. If it says no green balls, so remove green balls, pick from the remaining balls. Sorry, this will be 14c3. 4 green balls you remove, 6 plus 8, 14. So this becomes 14 into 13 into 12 upon 18 into 17 into 16. So this is 7 by 9 and 12 can be written as 3 by 4 and then this is 3 times. So this will be 7 into 13, that is 91, and 17 into 3 is, and 4 is 204. So this is the required probability. Next is all balls are of different colors. Okay. Now in this case, we have different scenarios. All balls are of different color means one red, one green, and one yellow. So we will pick one red ball in 6C1 ways, one green ball in 4C1 ways, and one yellow ball in 8C1 ways upon 18C3. So that will be 648 upon 18, 17, 16 upon 6. So upon 6 becomes this here. So I have written this way. Okay. Now 18, 6, 6, 36. So 2 times. Okay, and 4 8 32, it is 2 times of 16, so 4 by 17. And the last one is all balls are of the same color. Now all balls are of same color, we can have three possible varieties. One is all red, we can have all green, we can have all yellow. So what we will do, like we found for all red, we will find for all three and add the probabilities. Okay, so since the denominator is same, 18C3 only, and all red will be 6C3, or it can be a second possibility that all are green, and third possibility that all are yellow. 6C3, so we can count these 6 into 5 into 4 by 6, which is 20. 4 into, so NC3 is n minus 1, n minus 2. So 432 by 6, which is 4. And 8C3, if you remember, we did in a previous question also, it is 56. 18C3 is 18, 17, 16 upon 6. So we can calculate this. This will come as 51 into 16, 816. 80 upon 816. We can divide by 8. So this becomes 10 and this becomes 102. We can again divide by 2. It will be 5 upon 51. So this probability will come as 5 upon 51. So this covers the different kind of varieties that you can get in these questions, wherein you have different balls being picked of different colors. So how to select different combinations. Now there is another variety which is some person passing, some person facing, failing, both passing, both failing, etc. Now how to do these kind of questions? These are quite prominent in NMAT. Okay, like in the last year also I encountered these kind of questions. Okay, so these are the common varieties. It says probability of Manoj passing a test is 5 by 6, that of Jaswinder is 4 by 5. Now, what is the probability that none of them passes the test? So, Manoj and Jaswinder pass and fail. So, his passing is 5 by 6, so his failing will be 1 by 6. Jaswinder passing is 4 by 5, his failing will be 1 by 5. Now, none of them passes the test. That means Manoj fails and Jaswinder also fails. So the probability will be 1 by 6 into 1 by 5, which is 1 by 30. At least one of them passes the test. So this is probability of none. At least one probability is always 1 minus none. Whenever you have at least one, just remember it in case of selections also all minus none. So at least one passing this test is p minus 1 minus none. So 1 minus 1 by 30, 29 by 30. Only one of them passes the test. Okay, only one of them means either Manoj will pass and Jaswinder will fail, or we might have a second case where Manoj fails and Jaswinder passes the test. Okay. Now if we add this, this becomes Manoj passing is 5 by 6, Jaswinder failing is 1 by 5, plus Manoj failing is 1 by 6, Jaswinder passing is 4 by 5. 5 by 30 plus 4 by 30, which is 9 by 30 or 3 by 10. So this means exactly one of them, only one of them passes the test. Now there could be another variety that they ask that both pass. That is the easiest. Both pass means Manoj is 5 by 6 and Jaswinder is 4 by 5. So this is 2 by 3. So they might ask one of them passes, none of them passes, both of them pass, okay, and at least one of them pass. Okay, so these are the different varieties. If you are preparing for NMAT and SNAP and are looking for mock test, we provide mock test as well based on the latest pattern of both these examinations. So you can check the links given in the description of this video in order to enroll for the same. Now this is alternate game. Okay. In alternate game, they test the concept of infinite GP. So this is one of the questions which is being circulated by many students because it is a question which was asked in the official mock. Okay, so some of you must have encountered this question. How to solve this and similar kind of questions? Alice and Barry play a game in which they alternately toss a fair coin, beginning with Alice. Alice will win the game if she has a toss in which the coin lands face down. Now, face down, face up. What is face down, face up? So let us say face down is heads. Okay. So treat face down as heads to avoid confusion. Before Barry has a toss in which the coin lands face up. So let us say face up is tail. You can consider anything. Head, tail, you can consider. 1, 2 does not matter. So coin has two outcomes, face down and face up. So you can call it face up as tail, you can call it face up as heads. If you take face up as heads, take face down as tail. So it does not matter what you consider. Okay. Now Barry will win the game if he has a toss in which a coin lands face up before Alice has a toss in which the coin lands face down. Okay. What is the probability that Barry will win the game? Now these two people are playing the game. Now Alice starts the game. Okay. Now what will happen is if Alice gets heads, Alice will win. Suppose Alice throws the coin and gets heads. So Alice wins. So we will not consider this case. Now suppose Alice throws the coin. Alice gets a tail. So Alice will not win. Now it is Barry's turn. Barry will win when Barry gets a tail. So if Barry gets a tail, Barry will win. So this is the first case that head and tail. So this is the case that we will consider Barry wins. Okay. Now next case is if Alice starts, Alice gets a tail, Alice will not win. Barry has to win. Okay. Now what if Barry gets a head? Barry will not win. So we will keep on repeating, right? So as soon as Alice gets a tail, a head, Alice will win. Or Barry gets a tail, Barry will win. Okay, so now this is now suppose Alice gets a head. So again Alice will win. So we will not consider this case also. Now if they throw tail head, Alice again throws tail, and Barry throws a tail. So Barry will win. So this is a favorable outcome. So we will ignore the unfavorable outcomes. Now suppose in this case also Barry gets a head. So they will keep on playing. Now keep on playing means Alice should get a tail because Alice gets a head. Alice Barry cannot win. Okay, so Alice should get a. So we should have a sequence like this: TH. Now we cannot tell that at which outcome will they win. So this will keep on going. So they will keep playing unless Alice gets a head or uh, Barry gets a tail. Sorry, this will be tail here and tail here. So we have to make Barry win. Okay, what is the probability that Barry will win the game? Okay, so Barry will win if Barry gets a tail. And this is the turn of Alice. This is the turn of Barry. So I'm highlighting Alice's turn. So Alice should continue getting tail. And as soon as Barry gets a tail, Barry wins. So these are the outcomes that you will get. Then this will go infinitely, can go infinitely. Now in this case, Alice gets a tail is 1 by 2. Barry gets a tail is 1 by 2. In this case, it is 1 by 2 into 1 by 2 into 1 by 2 into 1 by 2. 1 by 2 into 1 by 2. So we'll get 6 times. And this will be 8 times. So what are we noticing? We are getting a GP. Like it says 1 by 4 plus 1 by 16 plus 1 by 64 and so on. 1 by 256 and so on. What is the sum of infinite GP? Sum of infinite GP is A upon 1 minus R. So A refers to the first term. First term is 1 by 4 and R is common ratio. So we are multiplying by 1 by 4 every time. So that is the common ratio. 1 minus 1 by 4. So 1 by 4 upon 3 by 4. Since the denominator is same, we can say it is 1 by 3. So Barry wins is 1 by 3. You can calculate for Alice also and subtract from 1. That also will give you the result for Barry. Okay. So this is the way to solve these questions. You make an infinite GP and find the sum of that infinite GP. Now the next one that we are going to do is called Bayes theorem. Okay, so if you have not studied Bayes theorem, do not search for it on the internet because you will get some fierce result. It will be difficult to understand. ठीक है, सर्च कर लेना बेस थ्योरम और किसी से पढ़ के कोशिश करना समझने की. एनी बुक इफ यू फाइंड, एक बहुत गंदा सा लिखा होगा बी स्लैश ए बी, PAB, you will not understand what it is. When I was in school, I also did not understand what it was. Then I later learned it and then realized, okay, this was so simple. But our NCRT books and our teachers back then made it very complicated. So let us understand in a very simple way. Now, bag 1 contains 4 white and 6 black balls, while bag 2 contains 4 white and 3 black balls. One ball is drawn at random from one of the bags and it is found to be black. Find the probability that it was drawn from bag 1. Now, in Bayes' theorem, it is called conditional probability. What happens is partial outcome is known to us. Okay, partial outcome is that the ball is black. Okay, and we have to find that it was from bag 1. So basically, our probability is we have to find black from bag 1. And what is given to us, we do not have to find the total outcome. Our denominator in this case becomes what is already given to us. What is given to us? That it is a black ball. Okay. Now let us see these two bags. One is bag 1 is 4 white and 6 black, and this is 4 white and 3 black. Okay. Now this is bag 1, this is bag 2. What is the probability of picking bag 1? We have two bags, so both of them have a probability of being picked by 1 by 2. Okay. Now, when we have to find black from bag 1, so how do we find this? Black from bag 1. So first we pick bag 1 and black from it is 6 by 10 or 3 by 5. Now in the denominator we have black ball. Now black ball can be from bag 1 also and it can be from bag 2 also. So what is the probability of black from bag 1? We just wrote in the numerator. And black from bag 2. Black from bag 2 will mean first of all we will pick bag 2 and in this we have black as 3 by 7. So this becomes our probability. This will be 3 upon 10 or 3 by 10 plus 3 by 14. So simplifying we will get 3 by 10 into, this is 70 is the LCM, 21 7 times, and this is 5 times. So 21 plus 15, 36 by 70. So 36 by 70 means 70 by 36. So the probability is 7 by 12. This can also be done by making a tree diagram, which you will find easy to understand. So we have two bags, bag 1 and bag 2. They can be picked in 1 by 2 ways, 1 by 2 ways. Okay. In bag 1 you have 4 white and 6 black balls. So Black balls can be picked, white balls can be picked in 2 by 5 ways, black balls can be picked in 3 by 5 ways. In bag 2, we have uh, 4 white and 3 black balls. So this can be picked in 4 by 7 ways, black can be picked in 3 by 7 ways. Okay, so what do we have to find? We have to find black from bag 1. Black from bag 1 is this. Okay, so 1 by 2 into 3 by 5. And denominator is black ball. So black ball we will get is one is this thing, or we can get black ball like this also. So this into this. Okay, so this is 1 by 2 into 3 by 5. This is black ball, this is the numerator, and denominator is black ball. So we will add this part and this part. So this is your numerator, this is the denominator, this plus this is the denominator. So we will solve it this way. Okay, so you can understand through tree diagram also, or you can understand through the direct thing what you get as the outcome. Now let us see one question which has been a popular one this time, being asked in official mock from many of the students. कई लोगों से पूछा गया ऑफिशियल मॉक में, सो अगर आपसे भी पूछा गया है, आपको सॉल्व करना नहीं आया, if you watch this video, if you're lucky enough, you will know how to solve this. Okay, this is the exact question. The probability that it will rain tomorrow is 1 by 4. The probability that Chris will be late to his office, given that it does not rain tomorrow, is 1 by 5 by 6. And the probability that Chris will be late to his office, given that it rains tomorrow, is 2 by 3. What is the probability that it will rain tomorrow, given that Chris is not late to office? Okay. Now, what we will do? First of all, we will write all the probabilities. Rain की probability कितनी है? 1 by 4. Not rain, you can write like this, or you can write any symbol. Not rain ki probability 3 by 4. Okay, now it says Chris will be late to his office if it does not rain. So late not rain is 5 by 6. Okay, now we are given that Chris is not late to his office, so late is 5 by 6. So not late, it does not rain is 1 by 6. Now we are also given that late to office it rains is 2 by 3. So this means that if it rains, he is not late is 1 by 3. Okay, so this is the probability that is given to us. Now what is the question asked? The question asked is we have to find the probability that it rains, and what are we given? We are given that he is not late to his office. Now let's go back to the previous question. What we did, what was given to us? It was black. So probability of black in the denominator and probability from bag 1. We had to find this. Now here what we are given? We are given Chris is not late. This probability we have to find, and this is the thing which is given to us. Chris is not late. What is we have to find? We have to find that it will rain and not late. So probability rain and not late. Okay, so just see, like in normal other questions, what we do, we say is probability is favorable outcome upon total outcomes. Here total outcomes limit to the condition which is given. Like in the previous question, it was given that it is a black ball. So denominator is probability of black ball. Here the denominator is he is not late, because that is already given to us. Now P, it will rain and not late. What is the probability of raining? 1 by 4. And if it rains, he is not late. The probability is 1 by 3. Now he is not late. So not late means there are two cases. Like in the previous question, black ball was two cases, either black from bag 1 or from bag 2. Here he is not late. There are two possibilities. One is not late because of not rain, or he is not late but it rained. Two cases. He is not late, right? So he can be not late because of two different reasons. There can be multiple reasons also. In that case, like in this case, I have only two. Okay, this itself makes a problem complicated. So 1 by 4, 1 by 3 means that he is rain and not late. So rain and not late we already know is 1 by 4 into 1 by 3. And second category is not late and did not rain. Not late and did not rain. So did not rain probability is 3 by 4. And he is not late when it did not rain is 1 by 6. So this becomes our required probability. Numerator, it did not rain, it rained and he was not late. So raining probability is 1 by 4. He is not late when it is raining is 1 by 3. So one part of the denominator is same. Second part will be it did not rain and did not rain probability is 3 by 4 and he is not late when it not rains is 1 by 6. So we will get 1 by 12 upon 1 by 12 plus this is 3 by 24 or 1 by 8. So 1 by 12 into this is 2 plus 3 5 upon 24, which is 2 by 5. So this is the required probability. Many of the students are getting this question in the official mock. So if you have not been able to solve the question, now you know that how to solve this question. If you are preparing for NMAT and SNAP and are looking for a structured course where you get all these topics being taught in detail along with practice sheets and dedicated support group for doubt resolution plus access to NMAT and SNAP mocks, you can enroll in our course and we have slashed the prices for the same. You can check the link in the description of this video. And if you are targeting these two examinations and are looking for relevant mocks that will help you practice for these exams, you can get the same on our platform. And we also launched a grammar book recently, which has helped several students. It is not only helpful for NMAT, SNAP, but also for other MBA entrance examinations, which test you on grammar. It has 160 plus rules with examples that will help you strengthen your grammar skills and help you do good in these exams. So this was a comprehensive class on probability covering the different kinds of questions that you can anticipate in NMAT. So here are 5 questions for you to answer in the comments of this video. Take a screenshot of this and then try solving it, and please do answer in the comments of this video. And do let me know that if you enjoyed the session. So don't forget to subscribe to my channel for great content. Here you get the best content that you will find on internet for MBA preparation, and also follow us on social media platforms. So that's it about probability. I have covered almost the all types that you get, and including the ones which are being asked in the official mock, so that you know how to tackle these different kind of questions in the examination. Thanks for watching this video.